Now there will be a change in story. Now we're going to look at the case from the normative perspective, so make good decisions. So far we discussed the descriptive perspective. For instance, we had the example of the insurance company going to Amsterdam or Rotterdam. Then it used these simple measurement questions to find out the utility function of people in Amsterdam or Rotterdam. Then it could calculate what in complex insurance decisions, how much premium people want to pay for it. And then they could see where they make most money, Amsterdam or Rotterdam, there they go. All of this utility measurement, they use expected utility to model this client decision. This was descriptive. They did not really care at that moment if these clients were rational or not. Just whatever they do, wherever they pay the highest premiums, that's where they go. So it was a descriptive empirical problem. But now, from now on, we're going to discuss all these cases from the normative perspective. And there you can use the same techniques that we discussed before. For instance, if you have to take a big, complex decision, you may ask yourself, what would I do in simple situations like the standard gamma conditions? They are more easy to make up your mind. They show you what the essential trade-offs are, what your utility function is. Then from that, you can calculate what in the real decision is your optimal decision. This is, for instance, done when decision analysts give consultancy to companies. They talk with CEOs. What would you do? How do you think about this situation? They make up the mind what the attitude of the company to what risk should be. Then they know how to decide in situations. Another example is the health domain. In the health domain, we often use these quality of life measurements I already showed you. And we want to use them to do the best decisions, the best treatment, where how can we spend money that we gain the most quality of life that is possible. So those are normative applications, and the theory is useful there just as much. So then, now from we considered this case before. We have the simple measurement, I have the more complex the film measurement. They give different results. Imagine now you are in a normative context. You're thinking about good decision. You thought very careful about your decision. You really thought this P prime, that's exactly what makes me indifferent here. I very well contemplated this P, exactly what makes me indifferent here. These really represent my true preferences, but P is not equal to P prime. So what to think about this normatively? Well, maybe you can pause the video and think a bit, make up your mind a bit. But I'm going to continue now to discuss my perspective of the case. I think if this happens, you are not rational. In at least one of these two situations, you are not doing what is best for you. And you may be, well, it's a bit like the first meeting, you may think you need divine powers to say such a thing. Only God can really know what is best. If you want to know what is best for people, you have to know whatever they can buy with money, how useful it is for them, how much happiness it gives them, how are they in a family, what happens tomorrow. No human being can judge on that. Well, decision theory gives techniques for making such claim, and we don't need divine power. Well, you already saw it in the first meeting. Here's another example. I must say not everybody agrees. It's surely my opinion, and the majority of people agree with me in the field, but not everybody in the reasoning that follows. Let's assume P prime is bigger than P. P prime smaller than P gives similar stories, but let's assume that this is also the empirical realistic case, because a strong force going on is a certainty effect, that people overestimate the value of alpha. They ask too high a P prime to make them indifferent. So this is the empirically prevailing case. Anyway, it is the case that we're going to discuss now. Then I put up the preference here, but in the simple preference, I replace P prime by P. Well, P is smaller, so the lottery became worse. So if you really say that these are your two well-contemplated preferences, you must prefer alpha to this, because I worsened the lottery. So you say these are two preferences that you really have. Okay, I put them up in a new slide. Now I'm going to argue that these are irrational. That's my claim. Let me explain my reasoning to you. If I look here left, your preference, alpha is better for you than this. Understood. Now I look in the right situation. Lower branch gives the same C. So lower branch doesn't matter right or left. But upper branch, if I turn from right to left, I'm replacing this thing by something else that you like more, that you say is better for you. So I think the left should just be better, no? Lower branch, it doesn't matter. Upper branch is better. The only thing I did was improve something here. So I think if you here in the left you have that strict preference, here you should also strictly prefer left to right. You should not be indifferent. That's why I claim that these two preferences together are irrational. Now, I expect that stated in this simple abstract form, it sounds quite convincing that maybe most of you are indeed convinced that this is a rationality condition. However, in concrete situation, we'll see more special case where we put all kind of numbers here, then all kind of effects start coming in, psychological effects. In fact, what's going on here? There will be psychological interaction between upper and lower branch that I think are irrational, but they are going on in all the human beings. Many human beings have instinct to be open to all these psychological effects. Then there will be situations where you will may feel that you differently than what I say here. For instance, the famous Allais paradox will be such a case. And then you need to think, you have these instincts that tell you to do the Allais paradox, but you have this preference condition that your teacher says is rational. And you have to think what you find more convincing. And I know that really working on these emotions, these instincts, is not something you can do from one day to the other. It takes a lot of thinking and growing, if I may put it like that. And I know usually at the end of my course, where I do, as I'm doing now, my utmost best to convince everybody what rationality is, that these kind of conditions are irrational. Still, the majority of students will say, well, we think we rather do Allais paradox, or we rather violate your condition. But anyway, I'll do my best. So I'll put now up a preference condition formalizing what I said, the standard gamma consistency condition. It says, I'll put it up in one blow here. If in this simple situation you are indifferent, let me now take indifference here, then in a complex situation with the same P, you should also be indifferent. And the reasoning I told you before, if you compare these two, the lower branch, it doesn't matter. Upper branch, we replace some with something equally good. It's indifferent, so equally valuable. So you should be indifferent between these two. That is the standard gamma condition. And I claim it's a rationality condition. The majority of researchers think so, but many other researchers think it's not so. But then, okay, you sleep on it. But for now, give me this one. So I use it to go on to present to you the Neumann-Morgenstern surprise. The first meeting you saw the phonetic surprise. This will be the same pattern of reasoning, only in a different context. So the theorem says two statements are logically equivalent. It means that one is true if and only if the other is true. And it's a mathematical, you can just prove it, There's no discussion about it. It's just how it is. Statement 1, expected utility holds. Statement 2 is a list of preference conditions. Well, you saw it before the first meeting, the phonetic surprise. This is the same kind of thing, only different context. The preference condition, transitivity, completeness. You've seen it before. It's obvious. Let's not discuss now. Standard gamma. I did not explain to you what it means, but this means if you have a lottery of money and you improve an outcome, you just replace money amount with better money amount. You just like it. The more money, the better. So that's a quite trivial rationality condition. Standard gamma solvability I also did not define. It's a sort of continuity condition. It's a technical, not much. So that we need not discuss it so much. The crucial condition is standard gamma consistency. So we have already seen it's necessary for expected utility maximization. This theorem shows that essentially, ignoring the sort of trivial conditions, it's sufficient. Expected utility holds if and only if standard gamma consistency holds. And that's just a mathematical fact. Then all the discussion of a first meeting I can do again. If I want to convince you that expected utility is a rational model, I should convince you that these conditions, especially standard gamma consistency, are rationality requirements. Well, I did my utmost best for that. It can also be used to criticize. That's what Maurice Allais did. When von Neumann-Morgenstern published their theorem, Maurice Allais said, thank you, I'm going to use this to criticize your theory. He put up an example where he argued that standard gamma consistency was not good. And then he said, so I think expected utility is no good. So that can, the theorem is a neutral mathematical fact. It can be used pro, against, however. And again, also empirically descriptively, if you want to show that expected utility is violated, you must show that some of those preference conditions are violated. And verified, falsified, if and only if. Well, the whole same story as in the first meeting. This is another preference foundation. So let me well, you know now how it works, so I will not discuss it more. I hope you understand the importance of such theorems. Now I will go on to applications of expected utility, but that will be in the next recording.